$100,000, $300,000, or perhaps in the case of some OpenAI salaries,
$1 million.
These are some of the annual salaries that are possible when you become an AI engineer. AI engineering is one of the fastest growing, highest paying roles in tech right now, and the barrier to entry is not as high as you might think, especially if you already come from a software engineering background. But this is only true if you know what to focus on. Most people who try to break into AI either skip the fundamentals or chase the wrong skills entirely. So today I want to give you the clearest, most honest roadmap to becoming an AI engineer. But first, let's establish what AI engineers do in the first place. Simply put, an AI engineer takes existing powerful models such as GPT, Claude, Llama, or Gemini and build real useful applications on top of them. Chatbots, semantic search engines, document analyzers, AI agents that automate workflows, all of these are examples of the type of applications AI engineers build. You as an AI engineer are the person who makes these models actually do something valuable inside a product. Think of it this way. The AI model is the ingredient. You are the chef turning it into an actual meal. One thing to note is that AI engineering is software engineering at its core, and here's the part that a lot of overeager, inexperienced AI engineers tend to miss. The AI part is only part of the job. A huge part of the job is clean code, good system design, APIs, version control, and deployment. You know, all the things that kind of matter a lot in software engineering. Yeah, it's important in AI too. I'll go ahead and break down the roadmap to AI engineering success into 4 phases. Phase 1 are programming fundamentals. Here's a question that should take you less than 2 seconds to answer. Which of these languages do you think you'll need to know as an AI engineer? I'll wait. I'll assume you answered correctly and said Python. Python is a must-know language for AI, and you need to be comfortable with functions, loops, error handling, working with APIs, reading JSON, and managing virtual environments. Take the time to really learn this language and don't rush. Your future identity as an AI engineer will thank you for it. Alongside Python, you're also going to want to learn Git and GitHub. Version control is how real engineers work, and your GitHub profile is quite literally your portfolio you're going to use to represent yourself in interviews. In addition to this, you'll want to learn how APIs work conceptually, because as an AI engineer, you're going to be calling them a lot. Also, you'll want to grasp on machine learning concepts such as what embeddings are, what a model is, supervised versus unsupervised learning, training and testing, and regression and classification. You're going to want to also familiarize yourself with third-party Python libraries often used in machine learning, such as NumPy, Pandas, Matplotlib, and scikit-learn. Phase 2 is LLM or Large Language Model Engineering. It's important to get familiar with major AI APIs, such as OpenAI and Anthropic. From there, you want to master prompt engineering. Prompt engineering is the practice of designing and refining instructions to get more accurate results from AI models. The quality of your prompts directly determines the quality of your outputs, so you're going to want to take the time to really get a grasp on things such as system prompts, few-shot examples, and chain-of-thought reasoning. The difference between a prompt that works 60% of the time and one that works reliably is usually in the structure of your prompt. You'll also want to get into RAG, which stands for Retrieval Augmented Generation. This is one of the most practically valuable skills in the field of AI right now. The idea of RAG is simple. Instead of the model relying on purely what it learned during training, you retrieve relevant information from your own data at the moment a question is asked, so the model can answer using real, up-to-date, specific information rather than just its memory. In order to do this well, you'll need to understand embeddings and vector databases also. Also, take the time to explore Hugging Face, which is more than just a cute name. It's an enormous library of open source models for things like text generation, classification, image tasks, and more. It's great for experimenting without burning through API credits every single time. Once you're comfortable with direct API calls, you can start exploring frameworks like LangChain, which provide abstractions for building more complex applications such as chains, agents, memory, and tool use. The key here is to build something at each step. Do not rush this process. A simple chatbot, a semantic tool search, or a document Q&A system would be good examples of something to really make the knowledge stick. Phase 3 is where a lot of people actually get stuck: building production-grade AI systems. Context engineering is a skill that becomes critical as you move into more complex systems. It's the discipline of designing the entire information architecture around a model so it never gets lost. As your applications become more complex, you'll also want to learn how to orchestrate multiple steps and agents. Tools like LangGraph can help you build workflows with branching logic, tool use, and feedback loops, while MCP, or Model Context Protocol, gives AI applications a standardized way to connect with external tools and data. Fine-tuning is also worth understanding, even if you don't do it often. Fine-tuning allows you to take the foundation AI model and train it further with your own specific data, so that it becomes specialized for your exact task. Thanks to techniques like LoRA, which stands for Low Rank Adaptation, you can now fine-tune models efficiently without needing a rack of GPUs that would make your gaming rig jealous. Now, I want to give you a couple of areas to focus on that will help separate you from a good AI engineer to a great one. And the first is LLMOps. This is all about keeping your AI system alive and well after it's built. It's the operational side of keeping an AI system alive in production, such as monitoring and cost control. The second is structured evaluation, which is how you measure whether your AI system is actually working. Large language models are non-deterministic, which means the same prompt won't return the exact same response every time. This means you'll need tools and frameworks that can systematically measure things like hallucination rates, response consistency, and accuracy over time. Master both of these, and you'll stand out from the majority of candidates who've never even heard of them. Now, I know I just threw a lot of machine learning and AI concepts at you, and you're probably wondering where to actually start learning all of this. That's why I created a platform called The Gradient Descent that's made specifically for helping you learn all the necessary machine learning and AI skills. Once a week, I take a machine learning concept and I break it down in a way that actually makes sense. No complicated lectures, just clear, digestible lessons to make you actually get it. But it goes beyond just reading. Every week, you get 3 things: a hands-on collab where you can actually code in Python through guided exercises, a practice assessment with fully explained solutions, and a visual cheat sheet with illustrated explanations and Python code snippets. Not only that, but you have access to a constantly growing library of AI and machine learning lessons, with new lessons being added all the time. For example, say you want to learn RAG. Simply type it in the search bar, select a post, and go through the lesson and all the practice material. Oh, and when you sign up, you also get a free ebook, Machine Learning Simplified, which is essentially everything you need to understand machine learning from the ground up. Yours simply just for joining. Click the link below to try it free for 7 days, where you will have everything I mentioned sent directly to your email. And finally, phase 4 is to build your portfolio and get hired. 2 or 3 strong, well-documented projects will do more for you than a dozen half-finished ones. Focus on building things that solve real-world problems. Maybe that's a RAG system that lets users search through a large collection of documents, or an AI agent that automates a real workflow, or an application that uses AI to solve a problem that you personally care about. The specific project matters less than your ability to explain what problem you were solving, why you chose your approach, and how you built and evaluated it. For each project, make it feel like a real product. Deploy it if you can, record a short demo, and write a clear README file explaining the architecture, technologies you used, and what you learned. And make sure to treat your GitHub like a professional portfolio, because that's exactly what it is. On your resume, you want to be specific. List real and relevant AI skills that you actually know and can demonstrate, and back them up with projects. Most importantly, don't wait until you feel ready.
Nope.
Every phase of becoming an AI engineer is a lot like the AI workflow itself. You're constantly iterating and improving your abilities, and in order to do that, it's important to take action. In other words,
Just do it!
AI engineering is one of the most genuinely exciting spaces to be in right now. But the people who will actually thrive in it long term aren't the ones who chased the salary number. They're the ones who got curious, built real things, and kept learning even when the field kept changing under their feet. If there's a specific topic from this video that you want to learn more about, feel free to comment below on what you'd like me to cover. As always, thanks for watching, and I'll see you in the next video.